Good evening everyone. Welcome to Physics Master G classes. So today class is the GTM 1 paper. The first question is two waves are approaching towards each other with the velocity of 16 meter per second and the frequency is n. The distance between the two consecutive nodes is. So you know the concept behind it. In case two waves అనేవి opposing travel అవుతూ ఉన్నప్పుడు if they interfere or if they superimpose, they form the standing waves. So standing waves form అయినప్పుడు there is the concept of nodes and antinodes, right? So there forms nodes as well as antinodes. So nodes and antinodes form అవుతాయి, right? So node is a point where the amplitude is 0 and antinode is a point where the amplitude is a maximum, right? So this is ikkada e point is so e point దగ్గర amplitude 0, this point is amplitude 0, e point దగ్గర కూడా amplitude 0, and all these points are called as the nodes. So now he is asking consecutive nodes మధ్య distance ఎంత అని. So distance between this consecutive node is equal to, so this distance ఎంత, this distance will be equal to lambda by 2, right? Therefore the answer is lambda by 2, right? Answer is lambda by 2. So since you know lambda can be written as lambda is equal to velocity by f, right? Or you could say velocity is equal to lambda into frequency, and you could say this lambda is equal to velocity by frequency. So therefore lambda is equal to, here the velocity is how much, 16, and the frequency is how much, n. Therefore you can write this lambda by 2s. So you can write the lambda by 2 will be equal to how much is it? So this will be equal to 8 by n. That is the answer, right? So that is the question number 1. Now look at the question number 2. There are two monatomic ideal gases 1 and 2 of molecular masses m1 and m2 respectively are enclosed in a separate containers kept at the same temperature. The ratio of the speed of sound in a gas 1 to that in a gas 2. So since you know the formula for velocity of a sound in air will be equal to under root of a gamma RT by m, right? The formula is under root of a gamma RT by m. So since the temperature is same and both are having a same ideal gases, so therefore the gamma is also same and R also same. Therefore you could say this V is inversely proportional to under root of a molecular mass. Therefore V1 by V2 is equal to under root of m2 by m1. Under root of m2 by m1. So that is the answer for this question number 2. And the question number 3. There are 3 capacitors, each of capacitance C and the breakdown voltage of V are joined in series. The capacitance and the breakdown voltage of the combination will be. So you know in series connection, if the ideal capacitors are in a series, you can write the C equivalent equal to C by L, right? So therefore the C equivalent can be written as the C equivalent is equal to, you could say, which is nothing but C by N can be written as a C by 3, that is a C equivalent. And now we have to find out a voltage. So you know like Q is equal to C into V, right? And therefore the charge is same in both the cases. Therefore you could say this V is inversely proportional to the capacitance. Therefore you could say V2 by V is equal to, you could say, which is nothing but a C by C2. So therefore V2 by V is equal to, C is a C only, the C2 can be written as a C by 3. So therefore 3 will goes up, this C get cancelled. Therefore you could say V2 equal to 3 times of a V. Answer is this option number 3, right? Now this is the one more question. The dimensions of 1 by 2 epsilon naught e square, we have to find out half into epsilon naught e square. You could see here this formula is, what is formula? This formula indicates the energy density, right? That formula indicates the energy density, and you know the energy density formula. Energy density can be written as energy by volume. So what are the dimensions of this energy? Can be written as m L square T power minus 2 by volume can be written as the L cube. So this one get cancelled. Therefore answer is m L power minus 1 T power minus 2. And this is the question number, option is C. So here the electrostatic potential energy between the proton and electron separated by distance is, you know like whenever there are two charges separated by some distance, the potential energy can be written as, since you know the formula of U is equal to K Q1 Q2 by R, right? So here this U is equal to, K can be written as 9 into 10 power 9, right? Into Q1 can be written as charge of this one electron, sorry, charge of the proton can be written as 1.6 into 10 power minus 19 into charge of this electron can be written as minus 1.6 into 10 power minus 19, right? Let me write 1 second. So therefore U equal to K can be written as 9 into 10 power 9, right? And this Q1 can be written as, what is the Q1? 1.6 into 10 power minus 19, that is charge of what? Charge of a proton into minus 1.6 into 10 power minus 19 by, what is the distance here? The distance between them is 1 angstrom, therefore I can write the 10 power minus 10, right? But that will be in a joules. Now you have to convert that into electron volt. So therefore 9 into 10 power 9 into 1.6 into 10 power minus 19, so bringing this minus here, minus into 1.6 into 10 power minus 19 by 10 power minus 10 into this joule can be written as 1 electron volt by 1.6 into 10 power minus 19. So this one will be cancelled, therefore you get the answer approximately U is equal to minus 14.4 electron volt. So this formula is important, you need to keep this formula for the next exams. So please keep this formula in your mind. This U is equal to KQ1 Q2 by R, that you need to keep in your mind. And you have to remember one thing, that is what is a joules and electron volt conversion. So you can write this you can write 1.6 into 10 power minus 19, or you could say 1 joule equal to 1.6 into 10 power sorry 1 electron volt is equal to 1.6 into 10 power minus 19 joules. This is right. One second, you need to keep this in your mind, this relation. So 1 electron volt is equal to 1.6 into 10 power minus 19 joules. Therefore 1 joule is equal to 1 electron volt by 1.6 into 10 power minus 19. Clear? So next, coming to this one, the effective capacitance between the points P and Q of the arrangement shown in the figure is. Now here seems like a tough problem, but it is easy. So thing is that there is a voltage here, so voltage here. So you could say that ikkada voltage, they both are same. One second. The voltage here as well as the voltage here, they both are same. The voltage here and here, they both are same. That means they both are in a parallel. If they both are in a parallel, you know, like C equivalent is equal to, if they are in a parallel, you could say C equivalent is equal to C1 plus C2, right? C1 plus C2. If they are identical, you can write as a N into C, right? C equivalent equal to N into C. C equivalent is equal to N into C if they are identical, right? So just keep it also in our mind. C is equal to C1 plus C2, C equivalent is equal to N into C. Therefore, if these two are added, that will be equal to 2C. Therefore, I could say E don't need place, I'm just writing it as a 2 into C. Now have a look here. This is 2 microfarad and everything remains like a Wheatstone bridge. So this is, what is this? This is how much? This is equal to 2 microfarad. This is 2 microfarad and this is also 2 microfarad. This is also 2 microfarad and this is also 2 microfarad and this is 5 microfarad. Now it is seems like a balanced Wheatstone bridge, so therefore we can add these two and add these two. Now these two are in a series. If these two are in a series, that will be equal to how much? If those two are in a series, that will be equal to, if identical are in series, so C by 2, so this 2 by 2 will be equal to 1 microfarad, right? And here also this will be equal to 1 microfarad. It is also equal to 1 microfarad here, and along with this there is a one more capacitor here. How much is it? 2 microfarads, right? This is also 2 microfarad. Now these two are in a parallel, therefore that net will be like 2 microfarad. Again this 2 microfarad, this total 2 microfarad, this 2 microfarad in a series, therefore the answer is 1 microfarad. That is the answer. So answer is B. Clear? Now let's see this one. An electric bulb is designed to draw power P0 at a voltage V0. If the voltage is V, it draws a power P, then we have to calculate what is the P is. So now if you take a bulb, it is having a voltage rating as a V0 and a power rating as a P0. So from those power rating you can find out a resistance. Since you know the formula for power, P is equal to V square by R, or you could say P is equal to V into I రాయొచ్చు. At the same time P is equal to I square into R అని కూడా రాయొచ్చు, right? But since I know the voltage here, I will use this formula. All the formulas are important regarding the power. So P is equal to V square by R and P is equal to VI as well as P is equal to I square into R. But since I am using this formula because I know the voltage, so therefore I can write this P0 equal to V0 square by R, right? So therefore I could say this R is equal to V0 square by P0, V0 square by P0. That is what? Resistance. What is it? Resistance. Therefore ఇప్పుడు ఈ బల్బ్ యొక్క రెసిస్టెన్స్ ఎంతంటే ఇప్పుడు ఇదంతా కూడా ఇక్కడ డ్రాప్ అవుద్ది, ఈ వోల్టేజ్ అంతా కూడా ఈ రెసిస్టెన్స్ దగ్గర డ్రాప్ అయ్యింది. అలా డ్రాప్ అయితే అది కన్జ్యూమ్ చేసే పవర్ ఎంత అంటే దట్ కన్జ్యూమ్ పవర్ ఈజ్ ఈక్వల్ అగైన్ V square by R. Now this V is not rated voltage, it is this dropped voltage. ఇక్కడ ఉన్న డ్రాప్ అవుట్ సప్లైడ్ వోల్టేజ్ అనుకో. So therefore P is equal to V square is V square here by this R can be written as a V0 square into P0. Therefore the answer is V by V0 whole square into P0. That is the answer, right? Please keep these formulas. P is equal to V square by R, P is equal to VI, P is equal to I square into R. So depending upon that, these formulas can be used to find either the power rated, voltage rating as well as consumed kuda. Clear? So power rating కనుక్కోవడానికి యూజ్ చేయొచ్చు as well as the power consumption కనుక్కోవడానికి కూడా యూజ్ చేయొచ్చు. So that is the formula. So next one is this one. When a battery is connected across a resistor of 16 ohms, the voltage across the resistor is 12 volt. When the same battery is connected across a resistor of 10 ohms, voltage across it is 11 volt. The internal resistance of the battery is, right? So it is having some internal resistance, it is also having some internal resistance. So let me represent like this. It is having some internal resistance, it is also having some internal resistance R and R, right? So let's say it is having some voltage V here, or let's say it is voltage is epsilon, and let's say this voltage is epsilon, and here this resistor is how much? 16, and here the resistance is a 16 here, and here the resistance is how much? 10 ohms, right? Clear? And you know at the end of this, at the ends of this cell, the dropping voltage can be written as, or terminal voltage can be written as, what is the terminal voltage formula? If you remember, the terminal voltage formula can be written as, alright, what is the terminal voltage formula? Since V terminal is equal to epsilon minus I into R, so that is the terminal voltage. This is a terminal voltage, so please keep that in the mind. That is the terminal voltage formula, right? That is the terminal voltage formula. Vt is equal to epsilon minus IR. That is the terminal voltage formula if it is acting as a source. If it is acting as a source, that is source అంటే కరెంట్ ఆ బ్యాటరీ నుంచి బయటికి రావాలి. ఇన్ కేస్ కరెంట్ లోపలికి పోతే దట్ విల్ యాక్ట్ యాజ్ అ లోడ్. అప్పుడు నీకు టెర్మినల్ వోల్టేజ్ మళ్ళీ చేంజ్ అయ్యేది. ఎనీవే ఇక్కడ దిస్ బ్యాటరీ ఇస్ యాక్టింగ్ యాజ్ అ సోర్స్, దేర్ ఫోర్ ద టెర్మినల్ వోల్టేజ్ విల్ బి Vt is equal to epsilon minus R, right? Therefore now this terminal voltage, this voltage will be dropped here at this resistor. Therefore you could say Vt is equal to, let's say the current I is passing through this circuit. ఈ సర్క్యూట్లో కరెంట్ ఐ పాస్ అవుతుంది, కరెంట్ ఐ పాస్ అవుతుంది, కరెంట్ ఐ పాస్ అవుతుంది అనుకో, రైట్? నా ఇప్పుడు ఇక్కడ డ్రాప్ అయ్యే వోల్టేజ్ ఎంత అంటే ఈ వోల్టేజ్ అంతా కూడా ఇక్కడే డ్రాప్ అయ్యేది, ఇక్కడ ఈ రెసిస్టర్లో డ్రాప్ అయ్యేది. ఈ టెర్మినల్స్ దగ్గర ఉన్న వోల్టేజ్ అంతా కూడా రెసిస్టర్లో డ్రాప్ అయ్యేది. దేర్ఫోర్ ఇప్పుడు ఇక్కడ జనరల్గా ఇక్కడ డ్రాప్ అయ్యే వోల్టేజ్ ఏం రాస్తామంటే, ఇప్పుడు సే వోల్టేజ్ ఎట్ రెసిస్టర్ ఆర్ వోల్టేజ్ డ్రాప్ ఎట్ రెసిస్టర్ కెన్ బి రిటన్ యాస్ కరెంట్ ఇంటూ, రైట్? I could say current into resistance. I could say which is nothing but I into R, right? And here is mentioned something like, repeat the question again, when a battery is connected across a resistor of 16 ohms, the voltage across the resistor is 12 volt. So he's already mentioned the voltage drop here. ఇక్కడ ఎంత అంటే డ్రాప్ ఎంత, that voltage drop can be written as ఈ టెర్మినల్ వోల్టేజ్ ఎంత అయితే ఉందో ఇక్కడ అంతే డ్రాప్ అయింది. Therefore according to the logic the terminal voltage ఎంత 12. So 12 is equal to epsilon minus I into R, right? Same way, if it is connected across a 10 ohms, the voltage drop is 11. So therefore I could say this 11 is equal to epsilon minus I into R, right? So here the, let's say current is I1 here and let's say current is I2 here. This is the same again. Therefore if I just subtract them both, what I get 1 is equal to, so this will be cancelled, so this will be plus. Therefore I could say how much I get, I2 minus I1 into R. So that is what I get here. Clear? Now we have to find out that I2 minus I1. You need to get out this I2 minus I1. So therefore from here, you know voltage is equal to I into R, right? And therefore I is equal to V by R. I equal to V by R. Therefore I is equal to, what is the V here? What is the V? What is the voltage drop here? How much is it? 12. So 12 by, what is the resistance? 16. That will be equal to 3 by 4. Therefore I could say I1 is equal to 3 by 4. I1 is equal to 3 by 4. Same way from here I could say this I is equal to V by R again. I2. Therefore this I2 is equal to, what is the voltage drop here? 11 by 10. Right? Therefore if I substitute the values here, this 1 is equal to, I could say I2 minus I1. I2 is how much? 11 by 10 minus 11 by 10 minus 3 by 4 into R. Therefore if you do it, you will get this answer, right? You will get it as answer. Check it. You will get this 20 by 7 as answer. Clear? So next one. Next question is, a rigid circular loop of radius R and mass m lies in the xy plane of a flat table and has the current I flowing in it. Consider the z-axis to be vertically upward. At this particular place, the earth's magnetic field is B bar equal to Bxi cap plus Bzk cap. So this is Bxi cap and Bzk cap. The value of I so that loop starts tilting is, right? So normally there is a component BZ పైకి ఉంది అనుకో, ఇప్పుడు ఆ BZ వల్ల there won't be no torque. ఈ BZ వల్ల టార్క్ ఏమీ ఉండదు. ఎందుకు టార్క్ ఏమీ ఉండదు అంటే, ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ ఫైండ్ అవుట్ అ మ్యాగ్నెటిక్ మూమెంట్ హియర్ ఆర్ డైరెక్షన్ ఆఫ్ అ మ్యాగ్నెటిక్ మూమెంట్, ఇఫ్ యూ ఫైండ్ అవుట్ డైరెక్షన్ ఆఫ్ అ మ్యాగ్నెటిక్ మూమెంట్ హియర్, దట్ విల్ బి లైక్ అప్వర్డ్, రైట్? ఈ BZ యాజ్ వెల్ యాజ్ మ్యాగ్నెటిక్ మూమెంట్ రెండు సేమ్ డైరెక్షన్ ఉండడం వల్ల యూ నో ద టార్క్ ఫార్ములా, టార్క్ ఈజ్ ఈక్వల్ టు, యూ కుడ్ సే దిస్ MB sin theta. Torque equal to MB sin theta. So that is the one thing that you need to keep in your mind in order to solve this. So tau equal to MB sin theta, right? Tau equal to MB sin theta. Tau equal to MB sin theta. Here BZ as well as the magnetic moment, they both are opposite. They both are opposite, right? They both are opposite if you curl your fingers along the current direction. If you curl your fingers along current direction, the magnetic moment will be like into the board, right? Therefore magnetic moment will be into the board and this magnetic field will be along the z-axis. Magnetic moment is along negative z-axis and magnetic field is along a positive z-axis. Therefore the torque equal to 0 due to the BZ. Now what about this BX? So BX వల్ల ఏమైంది అంటే, the torque will be like, or ఇదంతా కూడా లోపలికి వెళ్ళి టార్క్ పైకి యాక్ట్ అవుతూ ఉంటుంది. Sorry, let me say torque will be acting towards along a positive y-axis. One second. ఈ BX వల్ల, రైట్? సో BX వల్ల టార్క్ అనేది ఇలా యాక్ట్ అవుతూ ఉంటుంది. ఎలా అంటే అలాంగ్ దిస్ పాజిటివ్ వై, అలాంగ్ పాజిటివ్ వై యాక్ట్ అవుతూ ఉంటుంది. దానివల్ల ఇది నీకు లోపలికి పోవడానికి ట్రై చేస్తూ ఉంటుంది. ఈ డిస్క్ ఏదైతే ఉందో, డిస్క్ అనేది తిరుగుతూ ఉంటుంది, ఈ లోపలికి పోవడానికి ట్రై చేస్తూ ఉంటుంది. లోపలికంటే ఈ సైడ్ ఏమో, ఈ సైడ్ అంతా బయటికి రావడానికి అండ్ ఈ సైడ్ అంతా కూడా లోపలికి పోవడానికి ట్రై చేస్తూ ఉంటుంది, రైట్? అలా పోకుండా ఉండాలి అంటే ఈ డిస్క్ యొక్క వెయిట్ వల్ల వచ్చే టార్క్, ఈ టార్క్ని బ్యాలెన్స్ చేయాలి. ఈ BX వల్ల వచ్చే టార్క్ని ఈ వెయిట్ వల్ల వచ్చే టార్క్ అనేది బ్యాలెన్స్ చేయాలి. సో దేర్ ఫోర్ యూ కుడ్ సే టౌ డ్యూ టు ద వెయిట్ షుడ్ బ్యాలెన్స్ టౌ డ్యూ టు ద BX, రైట్? So therefore I could say this is mg into r will be equal to tau can be written as, or tau due to the BX can be written as This can be written as a m bar cross b bar, right? So m into g into r is equal to m bar can be written as a I into a can be written as a pi r square into something like a k cap, right? I know, like, this is a area cross, you could say this is nothing but a bx I cap plus bz k cap, right? So if you do it, you will get the answer, right? So answer will be like, 1 second, I will do it. So mgr will be equal to, this can be written as the current here, right? This is the current, so this pi r square, and this is acting in, this can be written as how much is it? I is I, pi r square is pi r square only, k cap cross k cap, this will be 0, and k cap cross I cap, or is under 0 hypothesis, so you could say I into pi r square here, so this r get cancelled, therefore this I is equal to, there is a bx here, right? Sorry, right? This I is equal to, what is it? mg by bx into r, that's answer. So answer is this one. Where is pi is missing, so pi, sorry. So I is equal to mg by pi into bx into r, right? So this is one of the important problem for today's paper, so check it once. Now this one, a horizontal overhead power line is at a height of 4 meters from the ground and carries a current of 100 amperes from east to west, right? The magnetic field directly below it on the ground due to it is. So now the current is carrying like this from east to west, right? If you use your right hand thumb rule, you have to keep your thumb along this current direction. Then the magnetic field will be seems like this. 1 second, the magnetic field seems like what? Seems like this. I will draw the diagram. Seems like this, right? Clear. ఇలా లోపలికి పోయి జస్ట్ ఇలా లోపలికి వెళ్ళి మళ్ళీ బయటకు వస్తూ ఉంటుంది మ్యాగ్నెటిక్ ఫీల్డ్. ఈ కరెంట్ క్యారింగ్ వైర్ వల్ల ఇక్కడ లోపలికి పోయి జస్ట్ ఇలా లోపలికి వెళ్ళి బయటకు వస్తూ ఉంటుంది. సో అలా బయటకు వచ్చేటప్పుడు ఎస్పెషల్లీ ఈ పాయింట్ దగ్గర, సో ఈ పాయింట్ దగ్గర ఏమేది అంటే దట్ విల్ బి యాక్స్ టువర్డ్స్ సౌత్. ఇప్పుడు ఈ డిస్టెన్స్ ఎంత? డిస్టెన్స్ ఈజ్ గివెన్ యాస్, దిస్ డిస్టెన్స్ ఈజ్ గివెన్. what is the distance? Something is 4 meters, right? That is a 4 meter. Since the wire is infinite wire, we have to take it as like infinite wire. So magnetic field due to the infinite wire can be written as B is equal to mu naught I by 2 pi r. B is equal to mu naught I by 2 pi r. So that is the magnetic field due to the infinite wire, right? So therefore the answer is maybe which one? Either should be like, just do the calculation. So maybe answer should be one of this, maybe A, right? Check it once, take the calculations. The direction is towards the south, that is clear. And just substitute the values here, mu naught I by 2 pi r, then you will get the answer for that, right? So next one here. If the first order minima in a Young's double slit experiment occurs directly in front of one of the slits, if the distance between the slits is a d and the distance between the slits on the screen is capital D, then the wavelength of usual light is. Alright. So the distance between the slits is a d and here also capital D, and you know this distance is a y. It is forming exactly here. So therefore it is the first minima, right? Where is it? The first order minima. Since you know this delta x is equal to, you could say this delta x is equal to d into sine theta. That is a one formula that you have to keep in mind in order to solve this problem. The delta x is equal to d into sine theta, right? So here you could also say this formula is delta x is equal to d into the sine theta can be written as a y by capital D. And you know this delta x, what is the delta x here? So delta x is the first order minima, it is nothing but a lambda by 2. For first order minima, the delta x is a lambda by 2. The path difference should be equal to lambda by 2, therefore d here. And y is how much is it? Y is nothing but half of this d, which is nothing but d by 2 again. D is d by 2 into capital D. Therefore this 2 get cancelled and you get this lambda equal to d square by capital D. That is the answer for the question. Option is A, right? So there is a one more. a uniform electric field exists between a two opposite charged parallel plates. An electron is released from rest from the surface of the negatively charged plate. The electron strikes the surface of the opposite plate. So 2 into 10 power minus 2 meter from the first in 1.5 into 10 power minus second. Then the potential difference between the plates. So this is a negative charged plate. This is negative charged plate and this is a positive charged plate, right? You know, this electric field will create a force on it, or this electric field will apply the force on it. So you know, like E plates majlo there exists a voltage difference, and because of voltage difference there is electric field, and you know this V is equal to E into D, right? And you could say that this E is equal to V by D. So because of this voltage gap, because of this voltage difference, there exists an electric field. Electric field and E is equal to V by D. So therefore you could say and this electric field will apply some force on it, therefore it get acceleration. That acceleration A is equal to Q E by M. That is the acceleration. Because of this acceleration, it will move from here to here, and that will travel this much of distance. Therefore you could say that is starting from rest. If you use this kinematic equation, S is equal to ut plus half into A into T square. So since it is starting from the rest, you could say this S is equal to half into A into T square, right? Therefore you can write this formula as S is equal to half is half only, A can be written as a Q E by M, right, into T square. So therefore this S equal to half is half only, Q is Q, E can be written as a V by D, right? V by D into by M into, you could say, which is nothing but a T square. So therefore you know all the values, you know the S, which is nothing but 2, and this S and D both are same. So please keep that in mind. S and D, they both are same. They both are the distance between the plates. They both are same. So substitute the values, and before substituting the values, please keep all these formulas in the mind for the next exam, right? The formula that you have to keep in mind is V is equal to V equal to ED, and this A is equal to QE by M. And sometimes you have to use this formula also from the kinematics. S is equal to ut plus of AT square, right? So this is the next one from the ray optics. A light bulb is at a depth of D below the surface of the water. An opaque disc of radius R is placed on the surface of the water just above the bulb. The bulb is not at all seen through the surface of the water then. So normal ga, if you keep a bulb here, ikkada bulb place cheste, ee bulb nunchi vache light anta kuda that has to come through this circle, right? Ee circle nunchi vachudi because of from which concept it is? Critical angle concept. Critical angle nunchi idantha just ee circle nunchi vachudi. A circle radius already we find in a theory part. This circle radius already explained in a theory part. So the radius of this circle is, let's say the radius of this circle is R, capital R, right? The radius of this circle is capital R, and this distance is how much? This distance is capital D. This distance is capital D, right? The distance is capital D, right? This distance is a capital D. Now we have to find out this radius. So from this right angle triangle, you could say tan C equal to, right? You could say tan C is equal to, what is the tan C here? Tan C can be written as R by D. Tan C is equal to R by D, therefore this radius should be equal to D into tan C, right? And you could say this R is equal to D is D only. Tan C can be written as 1 by under root of n square minus 1. From where? From the logic of critical angle, you know critical angle formula, sin C is equal to 1 by n. From here you can write the formula. You have to keep the sin C is equal to 1 by n in mind. Alright, this one you have to keep in mind. So sin C is equal to 1 by n, just keep in mind, right? Therefore ఇప్పుడు ఇక్కడ వచ్చే లైట్ అనేది బయటికి రాకుండా ఉండాలి అంటే ఈ రేడియస్ ఎంత ఉండాలి? దట్ రేడియస్ షుడ్ బి, therefore this radius should be greater than d by under root of n square minus 1. N square minus 1, right? That was answer for that. Clear? So next, a lens is placed between the source of a light and a wall. It forms an image of area A1, A2 on the wall for its two different position, the area of the source is. So this is the concept of displacement of the lens concept. In a displacement of the lens concept, there is a concept that the magnifications will be equal. So first, for example, ఈ పొజిషన్ దగ్గర ఉన్నప్పుడు ఇక్కడ ఉన్నప్పుడు there are two positions పెట్టి చెక్ చేస్తాం. ఈ two పొజిషన్లో magnification లెట్ బి లైక్ ఫస్ట్ కేసులో magnification m1 అనుకో, సెకండ్ కేసులో magnification m2 అనుకో. This m1 into m2 will be equal to 1 in this displacement concept. So here, instead of taking a lateral displacement, we will take it as a aerial displacement. Magnification. So magnification and magnification will be equal to 1. Here we will, instead of taking this lateral magnification and longitudinal magnification, here we will take it as a aerial magnification. The aerial magnification formulas are area of a image or size of a image by size of the object into, here also size of a image by size of the object will be equal to 1, and the size of the image can be written here a1 by, I can write as a AO here, into this can be written as a a2 by AO will be equal to 1. So therefore a1 a2 is equal to a naught square. Therefore this a naught is equal to under root of a1 8, right? That is the answer for this one. So please keep this logic in the mind, right? This one. So this m1 into m2 is equal to 1, and you need to keep the aerial magnification also in the mind, that is size of image by size of the object, right? Next one, what should be the velocity of an electron so that its momentum becomes equal to that of a photon wavelength? Sorry. What should be the velocity of an electron so that its momentum becomes equal to that of photon of wavelength? So here you have to understand that the momentum of a photon and the momentum of an electron, they both are equal according to the question, right? So you know, since momentum of photon can be written as P is equal to E by C, P equal to E by C, that is the momentum of a photon, and that P is equal to E can be written as Hc by lambda, right? Into C here, the C get cancelled, therefore momentum of photon can be written as P is equal to what it is, H by lambda, and according to this question, this H by lambda is equal to m into V. Therefore you could say this H by lambda is equal to m into V. Therefore this V should be equal to, this V is equal to what? V is equal to H by m into lambda. So substitute all the values, mass of electron as well as this one Planck constant value, substitute everything, you will get the answer. And here you have to keep all these formulas in the mind here. So first one is this one, that is P is equal to E by C, momentum of a photon, and then you have to keep this in the mind, this P is equal to H by lambda, or that will be equal to m into V, right? And you have to remember the Planck constant also, 6.6 into 10 power minus 34, and you have to keep the mass of electron, how much is that? 9.1 into 10 power minus 31 kg, right? Please keep those also in the mind. In here there is a one more question. This is from electromagnetic waves. Question is no electromagnetic waves, no, it is, one second. A beam of cathode rays is first accelerated to a potential difference V and then is subjected to crossed electric and magnetic field. Now it is from moving charges and magnetism, right? The fields are adjusted so that beam is not deflected. The specific charge of the cathode ray is, right? So if the charge is not deflecting, the condition is, what is the condition? If the charge is not deflecting from the Lorentz force, you could say, one second, sorry, from the Lorentz force, if it is not deflecting, you could say this force due to this electric field will be due to the force due to the magnetic field, right? Therefore this q get cancelled. You could say this E is equal to V into B, that is velocity into B. So E is equal to velocity into B, so that is the logic. E equal to velocity into B, and now we have to find out this velocity, right? So since you know that kinetic energy formula can be written as half into m into v square, so this half mv square will be equal to q into v due to the voltage. the kinetic energy will be equal to work done by this battery. Therefore, you could say this V square equal to Q by, or I could say 2QV by M, right? So I know the V square here, therefore just squaring on both sides. So therefore this can be written as E square equal to, V square can be written as a 2QV by M into B square. So therefore, right, I could say this Q by M equal to, this Q by M is M E square by 2B square into voltage. So the answer is, sorry, there is M come this side, so there is no M here, sorry, my mistake, right? So E square by 2B square into V, that was the answer for this. E square by 2V B square, option A is the right answer for this. So already this question is done so many times, so please you do this question, I'm just leaving to you, right? You know the formula, right? Formula can be written as the delta M equal to, what is the formula of this? This delta M is equal to mass of the proton. So what is the formula for this? Z into mass of a proton plus A minus Z into mass of neutrons minus mass of this nucleus, right? Into mass of the nucleus. Clear? So that was the formula that you have to keep in mind in order to solve this problem. This is the one formula that you have to keep in mind. You will get this delta M here. You will get the delta M. Then you have to multiply with the 931.5. Right? Then you have to write for the binding energy. Therefore, binding energy is equal to this delta M into 931.5. Delta M into 931.5 into mega electron volt. This is the one more thing that you need to keep in mind in order to solve this. This one. Right? Just do the calculation, you will get it. So this is the direct one. So which is option is A. Next one is this one. The only logic here that you need to understand is, so three infinitely long charge sheets are placed as shown in the figure below. The electric field at a point P is. So there is a point P here, and before that you need to understand this one. Positive charge valla electric field eppudu kuda away untadi, and negative charge valla eppudu kuda towards untadi, right? So therefore this electric field is away from this charged body, and this electric field is towards the charged body. And there is a one more thing that you need to keep in mind here, that is, like charged sheet valla electric field anta ante, the electric field due to this charged sheet is E equal to sigma by 2 epsilon naught. E equal to sigma by 2 epsilon naught. So that is the formula for this, right? Now at the P, deen valla, so let's say I'm taking a P here. So E painunna charge valla, let's say E painunna charge valla ikkada electric field. E painunna plate valla ikkada electric field. That electric field can be written as in a downward direction, right? This electric field will be downward direction because that is a positive. It is a positive charge, so it is the downward direction. And due to this minus 2 sigma will also be in downward direction. Minus 2 sigma value that will be in downward direction, right? And this again, this minus sigma value that will be in a downward direction. The minus sigma value due to downward direction, so we have to add all this, right, in order to get the answer. Clear? Hope you get it. You need to add all these formulas. So in the place of first one, you have to add sigma by 2 epsilon naught minus 2 sigma by 2 epsilon naught minus sigma by 2 epsilon naught. You have to add them all to get the answer. Clear? So this one, a solid non-conducting sphere of radius r has a uniform distribution of charge working space throughout its volume. At a distance x from its center for x less than r, the electric field is directly proportional to, like direct formula, right? This is a direct formula based question. Electric field inside a solid sphere. The formula is E is equal to KQ R by R cube. This is the direct formula if you remember this electrostatics, right? So therefore just keep this formula in your mind in order to solve this. That is a direct one. So E will be directly proportional to this R, where this R is nothing but X. Therefore E is directly proportional to X, right? So this one. So in a Wheatstone network, P is equal to 2 ohms, Q is equal to 2 ohms, R is equal to 2 ohms, and S is equal to 3 ohms. The resistance with which S is to be shunted in order that the bridge may be balanced is. So in a Wheatstone bridge we can write the formula as P by this R is equal to Q by this S, right? So if those are equal, then for a balancing Wheatstone bridge, this P by R should be equal to this Q by S. That is the condition for the balanced Wheatstone bridge. So Wheatstone bridge and the balance of that is the condition. P by R is equal to Q by S. So here what is the P value? That is a 2. The P value is a 2 and the R value is also 2, right? Will be equal to this Q value is a 2, but S value is how much? 3, right? The S value is a 3. Now it is like unbalanced. So the balance sheet goes on, we are shunting a one more resistor here. Let's say if I shunt a R here, now these 3 and R will be in a parallel. If they are in parallel, I can add the 3 into R by 3 plus R, right? Now this one get cancelled. Therefore these two get cancelled. Therefore 2 by, or I could say will be like 2 by 3 into R by 3 plus R, right? Will be equal to what? 1. Therefore I could say 2 is equal to 3 into R by 3 plus R. 3 into R by 3 plus R, that will be equal to 6 plus 2R is equal to what? 3 into R. Therefore this R is equal to 6 ohms. R equal to 6 ohms, that is the answer for this question. Right. So next one, a uniformly charged solid sphere made up of insulating material has a potential 100 volt at its surface. What is the potential of the center of the sphere in volts? So again it is a formula based directly. The potential of a solid sphere inside it. Since you know the formula, V is equal to, you could say, K Q by 2R cube. You could say K Q by 2R cube into 3R square minus X square. This is the voltage formula, that is potential formula inside solid sphere. Right. So that is inside a solid sphere, the potential formula Kq by 2R cube into 3R square minus R square, right? Therefore V on surface can be written as, V of surface is equal to Kq by R only. This can be written as a Kq by R, and this Kq by R is equal to how much is it? 100 volt. That Vs is equal to Kq by R, that is equal to 100 volt here. Therefore now since it is a center, this X will be equal to 0. Therefore V at center can be written as 3Kq by 2R cube, right? So that will be equal to this into R square here, right? So this one get cancelled. Therefore this will be equal to 3Kq by 2 into R, right? And this Kq by R is how much? 100. Therefore 3 by 2 into 100, right? This will be equal to 150. That is the answer for that question. That is equal to 150. That is the answer for that question, right? Now this one. So there are three lenses L1, L2, L3 are placed coaxially as shown in the figure. Focal length of lenses are given as 30 cm, 10 cm and 5 cm respectively. If a parallel beam of light falling on lens L1 emerging at L3 as a convergent beam such that it converges at the second focus of L3, distance between L1 and L2 will be. So this is the lens L1 and this is lens L2 and this is lens L3, right? Clear? So now ఇప్పుడు ఈ ఫస్ట్ లెన్స్కి రేస్ అనేవి ప్యారల్గా వస్తున్నాయి. ఇప్పుడు ఈ సెకండ్ లెన్స్ నుంచి ప్యారల్గా వస్తే దీని నుంచి ఈ ఫస్ట్ లెన్స్కి దిస్ ఇన్సిడెంట్ రేస్ ఆర్ ప్యారల్ టు ద ప్రిన్సిపల్ యాక్సిస్. సో దే విల్ ఫోకస్ టు దిస్ ఫోకస్, రైట్? ఇవన్నీ ఏమవుతాయంటే ఎగ్జాక్ట్గా ఫోకస్ దగ్గరికి ఫోకస్ అవుతాయి, రైట్? ఫోకస్ దగ్గరికి ఫోకస్ అవుతాయి. బట్ దానికంటే ముందు ఇది ఏం చేస్తుంది అంటే దట్ విల్ డైవర్జ్. ఇది డైవర్ట్ చేస్తుంది. దేర్ఫోర్ ఇక్కడ నుంచి ఇక్కడికి డిస్టెన్స్ ఎంత అంటే ఫ్రమ్ దిస్ లెన్స్ టు దిస్ పాయింట్, ఈ ఫోకస్ ఎక్కడ ఉంటుంది, దిస్ డిస్టెన్స్ ఇస్ హౌ మచ్? This distance is given as a 30 centimeter. This distance is given as a 30 centimeter. The distance is given as 30 centimeter. This distance is almost 30, right? Idanta 30. ఇప్పుడు you need to find out ఇది 30 అయితే and ఇక్కడ నుంచి ఈ distance ఎంత? This distance is how much? 5. Sorry, 5, not the 5, 10. This is 10. ఇదంతా 30, ఇది 10. అప్పుడు ఈ గ్యాప్ ఎంత అంటే 20. That's answer. ఈ టోటల్ ఇస్ 30, ఇక్కడ నుంచి ఇక్కడికి ఎంత 10, అండ్ అప్పుడు ఈ డిస్టెన్స్ ఏమైంది 30 అయింది. దట్ ఈస్ ఆన్సర్. సారీ, ఈ గ్యాప్ ఏమైంది 20 అయింది. దట్ ఈస్ ఆన్సర్ ఫర్ దట్, రైట్? నౌ దెర్ ఈస్ వన్ మోర్ టాపిక్. So in a compound microscope, the focal length of the objective and the eye lens is 2.5 cm and 5 cm. So this is called as objective, which is having a focal length as a 2.5 cm, and it is having a focal length as a 5 cm, right? Respectively, an object is placed at 3.75 centimeters before the objective, and the image is formed at the distance of distinct vision. Then find the distance between the two lenses up to nearest integer in a centimeter. So the distance between these two, we have to find out a tube length. This tube length ani, and this eyepiece is forming at least distance of distinct vision. So this distance will be equal to 25 centimeter. And what is this distance? This distance will be equal to, what is it? How much is that? This is 3.75. That is 3.75. Therefore, you know the formula directly. If you remember the formula, you can write this tube length for this maximum magnification formula is, you can write it as you can write as a fu by f minus u plus f naught u by f naught minus u plus, you can write as a fe into d by fe plus t. So substitute all the values, you will get everything, right? So that is a shortcut for this. You need to keep this in our mind, right? What about derivation ante, when we have a free time, let's talk about that optical instruments again, right? Malli optical instruments gurinchi maatladam if you have a free time. So meanwhile, just keep this formula in mind. L is equal to f naught u by f naught minus u plus fe into d by fe plus t. So substitute these values, you will get the answer. Clear? Next one. A circular coil of 100 tons and effective diameter 20 cm carries a current of 0.5 ampere. It is to be turned in a magnetic field B is equal to 2 Tesla from position of its stable equilibrium to unstable equilibrium, right? If the current is here, if for example, let's say this is in a YZ plane, ఈ ప్లేన్ అంతా YZ plane లో ఉందనుకో, ఫర్ ఎగ్జాంపుల్ ద కరెంట్ మూవ్స్ ఇన్ అ క్లాక్ వైజ్ డైరెక్షన్, యూ హ్యావ్ అ మ్యాగ్నెటిక్ మూమెంట్ అలాంగ్ దిస్ వన్, బట్ అలాంగ్ ద మ్యాగ్నెటిక్ ఫీల్డ్. ఫర్ ఎగ్జాంపుల్ if కరెంట్ అనేది యాంటీ క్లాక్ వైజ్లో ఉంటే దిస్ విల్ బి ఆపోజిట్ టు ఇట్, రైట్? సో దిస్ ఈస్ ద ఫైనల్ కేస్. So this is the final case and this is the initial case, right? And since work is equal to, or energy formula, energy is equal to, the formula is minus m into b into cos theta, right? In this case, this theta is equal to 0, and in this case, this theta is equal to 180 degrees. Therefore, the work will be equal to, the work is this W is equal to U final minus U initial. So substitute it, you will get the answer, right? Just keep these formulas in your mind and just substitute the values, you will get everything, right? So that's the end of the paper. If you have any doubt, you can comment. If I have a time today, I will just upload that waves concept also, if I have a free time. So let me see whether I can do it or not. Maximum I will upload that waves if I have a free time, or else I will upload that tomorrow, right? So that's the paper. If you have any doubt, you can comment and I will just reply to your comment, right? Thank you.